So welcome to this class. In this class, we're going to discuss the solutions to the CAT that you did on 28th November 2024. And we'll start by briefly going through the overall class performance before narrowing down to the actual solutions to the problems. So the class has a total of 121 students, but only 107 students did the CAT. So which means we have 14 who never did the CAT. And these are the summary statistics for the overall performance after marking the CAT. So the class mean is 59.68807%. Majority of students scored a mark of around 60%. The range is 58%. The highest score was 88%, and the lowest score was 30%. Then this is the histogram that represents the performance of the class. And we can see that majority of students scored between 50s and 670. We have a fairly small tail, but still we can remove the whole tail and ensure that everyone can get above 40% in the final exam. And this is the list of the top performers. So the highest score was 88%, which was scored by Ogutu Dickens Otieno. And then the second high score was 86%, which was scored by Simatwa Levin Chelimo. The next high score was by Samia Hope, 84%. The next score, Karangwa Ishema, also 84%. We have Judith Atieno, 84%. Winnie Nduta, also 84%. We have Muindi, 80%. Tangaza Edric, 80%. And these are also other students who got marks above 70%. So if this was the final exam, then it means that the whole class will be having 25 clean S. So we can still improve on this result so that we can add more A's to this list and reduce the tail for those who have scored less than 40%. So let's now go to the CAT solutions. Now, the first question, A, we were given function f, 3x minus 2, g, 2x plus k, and we were told that f composed with g the same as g composed with f, find the value of k. So the key thing here was just for you to remember how to define the composition of two functions, f and g. So the first thing, define composition of f and g, which means f becomes the function, g becomes the input. So you replace g, which is 2x plus k. So when this is the input of f, and the way f operates is that when you give it an x, it multiplies that x by 3, subtracts 2. So the input you're giving f, you multiply by 3, then you subtract 2. Then it thus simplifies to 6x plus 3k minus 2. Then also define the composition of g and f. So this means g becomes the function, f becomes the input. So the input of g will be 3x minus 2. And by definition, when you give g an x, it multiplies that x by 2, adds k. So when you give it a 3x minus 2, it will do the same job. You take 2 times the input, 3x minus 2, then you add k. When you simplify, you get 6x minus 4 plus k. Then because we're told that the two compositions give the same value, then we equate these two solutions, this value and this other value. So when you equate and simplify, you get k to be minus 1. That is how you are supposed to answer part A of question 1. Then part B, let f be a function from the set of real numbers to the set of real numbers defined by 3x plus 2. Find the images of 1, 2, and 3. So images simply means the outputs. So where there's x, put 1. So when x is 1, f of 1 will be 5, f of 2 will be 8, f of 3 will be 11. So the images of 1, 2, 3 are respectively 5, 8, and 11. Then you get your 1 mark. Then find the pre-images of 29 and 53. So pre-images means the values of x. So here, it means that f of x is 29. So which means 2x, 3x plus 2 equals to 29. Then solve for x. So you get x is 9. Similarly, f of x equals to 53. Then f of x is 3x plus 2 equals to 53. So solving, you get x equals to 17. Identify the type of the function. Now, since all the elements of the set of natural numbers have different images in the codomain, then the function is a one-to-one function. So the codomain of f is n, but the range of f is 5, 11, 5, 8, 11, 14, 17, which is a proper subset of the set of real numbers, the set of the natural numbers. So it means that the range of f do not take all the set of natural numbers. So which means then the function f can never be a non-to function, because for it to be a non-to function, then the range and domain should be the same set. So therefore, we conclude that the function f is a one-to-one or an injective function. So B, we are asked, part C, we are asked to evaluate the limits. So the limit as x approaches 2 of x cubed minus 8 over x minus 2. So the first thing, note that x cubed minus 8 can be factorized as x minus 2 into x squared plus 6 plus 4. Then you write this numerator as factor, and then divide by x minus 2. So this x minus 2 and x minus 2 cancels out. So the expression reduces to x squared plus 2x plus 4. Then when you apply the limit, you get the value to be 12. Similarly, x cubed minus 27 can be factored as x minus 3 into x squared plus 3x plus 9. X squared minus 9 is a difference of two squares, which is x minus 3, x plus 3. So the numerator over denominator will be this factored expression or this other factored expression, which reduces to x squared plus 3x plus 9 over x plus 3, because x minus 3 and x minus 3 cancels out. Now, the limit now will be applied on this new function after crossing x minus 3. And where there's x, when you put 3, this reduces to 4.5. D, if the function f from the set minus 5 to 9 to the set of real numbers is defined piecewisely by this function, then find the values of. So f of minus 3 means f of minus 3 plus f of 2. So to define f of minus 3, then remember there are three parts of this function f. When x is from minus 5 to 2, you use minus 5 to strictly value less than 2, you use x plus 6x plus 1. When x is exactly equals to 2, but strictly less than 6, you use 5x squared minus 1. And when x is equals to 6 up to and all values including 9, you use 3x minus 4. So there are three parts. And so for you to know how to define the f values, you need to understand the x value to know which of the three parts actually is the correct one to use. So minus 3 is a value between minus 5 and 2. So therefore, to define f of minus 3, we use the first part, 6x plus 1. So when you do that, you get values minus 17. F of 2, 2 is in this part, because this way I have 2 less than or equals to x. So replace 2, we get 19. So f of minus 3 plus f of 2 is 2. F of 7, 7 is between 6 and 9, so we use this third part. So we'll have this as 17. F of 1, 1 is between minus 5 and 2, so we use the first part. And then when you subtract 17 minus 7, we get 10. Two f of 4 plus f of 8. So first define f of 4. 4 is between 2 and 6, so use the middle function to define f of 4, which is 79. F of 8, 8 is between 6 and 9, so use this third part. So which will give us f of 8 is 20. So 2 f of 4 means 2 times the value of f of 4, which is 79, then plus f of 8, which is 20. So when you work out, when you put them together, you get 178. So similarly, you define f of minus 2, which is minus 11, f of 6, which is 14, f of 4, which is 79, f of minus 2, given by minus 11. So replacing and simplifying accordingly, you get the final answer to be minus 9 over 17. So if A is a set with elements minus 2, minus 1, 0, 1, 2, and f is function from A to B is an onto function, where f is given by x squared plus x plus 1, then find the set B. So these are the inputs, because A is the domain from the definition of this function. So where there's x, put 2, put minus 2, minus 1, 0, 1, and 2. So these are the values. F of minus 2, 3, f of minus 1, 1, up to f of 2 is 7. So 3, 1, 1, 3, 7 forms a set B. And when you are listing the elements of a set, repetition does not create new elements. So then we just write B as 1, 3, and 7. Because 1 is repeated and 3 is repeated. So just write it on. So let f of x be 3x squared minus 1 if x is less than 0. F of x is alpha x plus beta if x is between 0 and 1. And if x is greater than 1, f of x is square root of x plus 8. We need to determine alpha and beta so that f of x is continuous everywhere. So for f of x to be continuous at x equals to 0, the left-hand limit must be the same as the right-hand limit. So this by definition. And so the left-hand limit, right-hand limit, and the value of the function at 0, it should agree. So the left-hand limit means we use this function, 3x squared minus 1, because this part is what defines x values less than 0. So when you substitute here, we get the limit of it to be minus 1. Then f of 0, 0 less than or equals to 1. So it means that for you to find the value of the function at x equals to 0, you need to use the second part. So then f of 0 is alpha times 0 plus beta, which is beta. So with this condition for continuity at x equals to 0, then it means that the value of the limit and the value of the function at 0 must agree. So beta is minus 1. So for f of x to be continuous at 1 also, the left-hand and right-hand side limits should be the same, and the value of the function at 1 must also be the same. So left-hand limit as x approaches 1, it'll be using this function. So I'll have alpha times 1 plus beta, alpha plus beta. Then right-hand limit will be using this other part. So we'll have 9, root 9, which is 3. So then for this function to be continuous at x equals to 1, the left-hand and right-hand side limit should be the same. So equate alpha plus beta to 3, knowing that beta is minus 1, alpha is 4. GF is a function from the set of real numbers to the set of real numbers defined by 3x minus 5. Find A and B given that A, 4, and 1, B belongs to F. So remember the first number is X value, second number is the F of X value. So F of A is 4. So given that this F of X, so F of A will be 3A minus 5. So 3A minus 5 is 4. So 3A equals to 4 plus 5, which is 9. So A is 3. Then f of 1 is B. So f of 1 will be 3 times 1 minus 5, which is minus 2. So B should be minus 2. So the question 1, part H, build a digital circuit that produces the output given by this, where the given input bits are P, Q, and R, and also draw the truth table. So this is the required circuit. And then this is the required truth table. So remember, when we are drawing the truth table for this digital, we use 0 and 1s, so binary units or components. Question 2, given that f is this, find the inverse and range of this inverse function, inverse f, and then check whether f inverse is a function or not. So remember, the domain of the inverse is the set of all the so the inverse means first elements become second elements and second elements become the first elements. So just swap. So 2, 1 becomes 1, 2, 3, 2 becomes 2, 3, minus 3, 3 becomes 3 minus 3, 0, 4 becomes 4, 0. So this is the F inverse. Now the domain is first element in each of these pairs. So I'll have now the domain is this set, and this is the range, second elements. So to plot means simply plot these values in the Cartesian plane, and they are just actually points. So you don't join them with a line or a curve, just leave them in the form of points. So to determine whether the inverse relation is a function, we check if each input, first component in the F inverse relation, maps exactly to one output. So from these values of F inverse, we can clearly see that each input is unique and maps to exactly one output. So therefore, F inverse is a function. So in a survey conducted among 360 civil engineering students, researchers determined their preferences for 3 areas of specialization: structural engineering, geotechnical engineering, and transportation engineering. The following results obtained: 18 students specialized in all 3 areas, 171 specialized in structural engineering, 138 specialized in geotechnical engineering, 155 specialized in transportation engineering, and 29 students did not specialize in any of the 3 areas. Based on this information, how many students specialized in exactly 2 of the 3 civil engineering areas? So let S be those who specialize in structural engineering, G those who specialize in just technical engineering, and transportation engineering be T. So these are obvious values you can read from the given information. And since we are told that 29 are not specializing in any of the 3 areas, so we clearly see that the cardinality of the union of the 3 sets will be given by the difference between the total and this 29, which is that one. So by using this inclusion-exclusion principle, and remember, for us to get those who specialize in exactly 2 of the 3 areas, it's easier to draw a Venn diagram and represent those points. So where I've labeled A, B, and C are the sections which mean someone is having a specialization in 2 of the 3 areas. So using the values given in the question and the parts I've labeled this Venn diagram, you form an equation, and then simplifying, you get that the sum of A plus B plus C is 97. So 97 is the required solution. So determine the points of discontinuity if any of the function 3x plus 3 over x squared minus 3x minus 4, and write an equation for each vertical and horizontal asymptote of the graph of f. So the best way is to factorize the expressions both in the numerator and denominator. And so this is what you'll have. And when you equate 0 to the denominator, we get x equals to 4 and x equals to -1 are the points of discontinuities. And these same points of discontinuities, x equals to 4 and the line x equals to -1, are what forms the vertical asymptotes. In simple terms, to get vertical asymptote, if you have been given a function, is as a rational function, is as good as equating the denominator to 0 and then solving for x. Then horizontal asymptote is the same as getting the limit of the given function as you approach plus or minus infinity. And when you get the limit of this function as x approaches plus or minus infinity, you get 0. So the line y equals to 0 is a horizontal asymptote. So evaluate this limit. So you see that when you substitute directly the infinity, then you get infinity. So the best way to do, you can first, okay, you can use this approach, try to factorize, and then try to play with this discriminant and see how you can reduce the expression. Or the most obvious thing, once you see a root sign, then it tells you that there is some aspect of rationalization. So you rationalize the numerator, and when you rationalize the numerator, you get x over square root of x squared plus x, then plus x. Then you try to play with this expression inside the root sign, which can be written as x squared into 1 plus 1 over x, which you can now factor out x, so that we have x square root of 1 plus 1 over x. Then substituting back, x is outside this root sign, and we have another x here. Then you can also factor out this x. So once you have that, then this x and x cancels out, and then you have 1 over square root of 1 plus 1 over x plus 1. Then now here you apply the loss of limit. So limit of this new expression is the same as limit of the numerator over limit of the denominator. So limit of this square root function, you can, as x approaches infinity, you can put in the limit, and then limit of 1 is 1, limit of 1 over x is 0, limit of 1 is 1. So when you substitute, you get the value of the limit is a half. Then similarly here, when you do direct substitution, you see that the numerator will be 0, denominator is 0, so direct substitution doesn't work. So once you see a square root, then the most obvious trick to work with it is to rationalize the numerator. Then when you rationalize the numerator, we get the numerator will be x squared minus 4. Denominator is square root x squared minus 2x times this bracket involving the root sign. So do further factorization here. So x squared minus 4 is x minus 2, x plus 2. X squared minus 2x is x into x minus 2. So rewriting, we get x minus 2, x plus 2 over x into x minus 2 times this bracket. So x minus 2 cancels out. So we remain with x plus 2 over x into this root function. So at this point, when you now supply the limit, then you must get something that actually works, that will not give you indeterminate forms. So that reduces to a third. And then this other one, now we have been given a function f, we have g, we have h, and then the composition of f, g, and h. And then we are asked to find the values of alpha, k, beta, and alpha minus beta, alpha minus k. So the first thing is to define the composition of f, g, and h. So means what is to the left become the function, what is to the right become the input. So step 1, f become the function, g and h become the input. And then the next step, g become the function here, h become the input. So this is what you'll have. The g of h of x will be given by this expression. So that once you get g of h of x, then you put it as the input of f, and it will give you this expression. Then expand in the usual way, the square of this, which will give you this as our final expression for the composition. And because we are already told that the composition of f, g, and h is 12x squared minus 20x plus beta, you equate the coefficients of x squared, x, and this constant terms, and then you get k is 6, and then get alpha is 8, and you'll get that beta is given by 3. So therefore, alpha is 8, K is 6, beta is 3. And then when you replace in the values of K, alpha, and beta, alpha minus beta, alpha minus K will give you 10. So it can be shown that this inequality holds for all values close to 0. What, if anything, does this tell you about this limit? Give a reason. So this means that this quantity is bounded between this function and 1. Then the limit of this function as x approaches 1 is also 1. So which means that this function, the left hand side is having limit 1 as x approaches 0. Similarly, as x approaches 0, this is 1. So by sandwich theorem or by squeeze theorem, the limit of this function, which is bounded between 1 minus x squared over 6 and 1, must be 1, because the two functions on left and right hand side have same limit as x approaches 1. So a survey was conducted among the top 500 civil engineering specialists. Out of these, 310 held degrees of any kind in civil engineering, 238 held undergraduate degrees in civil engineering, and 184 held postgraduate degrees in civil engineering. How many professionals held neither undergraduate nor postgraduate degrees in civil engineering? So know that their key sets here are those who have done undergraduate degree in engineering and those who have done postgraduate degree in engineering. So this is a Venn diagram for this. So because we've been told that only 310 did any of these two degrees, then we can get those who actually didn't do any of these two courses, these two degrees, by simply getting the total minus the 310, which is 190. So then this 190. Then the union of these two sets is now 310. So using the inclusion-exclusion principle, you can actually say that the intersection of the two sets is 112. So those who held both undergraduate and postgraduate degrees in civil engineering is 112. Please note that here, this portion of 72, it is possible that someone who didn't do an undergraduate degree in civil engineering can be allowed to do a postgraduate degree in civil engineering. So that's why we are not taking this 72 as part of our answer for those who have done both undergraduate and postgraduate degrees in civil engineering. For this portion of 72, may or may not. So therefore, we can't conclusively include this on that set of those who have both undergraduate and postgraduate degrees in civil engineering. So held undergraduate degrees in civil engineering, but no postgraduate degrees in civil engineering is obvious. This is just this portion of 126. Held at most 1 degree in civil engineering. At most means that value and anything less. So when you say at most 1 degree in civil engineering, these are those who only have undergraduate degrees. But if you are here, you can still have both undergraduate and postgraduate degrees in civil engineering. So therefore, those which are exclusively having 1 and less is this number 126 and this number 190. So we get the sum of those two, which will give us B16. Held exactly 1 degree in civil engineering will be 126. And then the explanation has been given. So define the or and not gates as used in Boolean algebra. This is bookwork, you can clearly see. And then lastly, find the disjunctive normal form of the following combinatorial circuit under the truth table. So this is the combinatorial circuit, and then disjunctive normal form is given by this. And then here is the truth table. Then lastly, find the output of each of these combinatorial circuits. So there's this first circuit and this second circuit. So the value for the first circuit is given by this, while the value for the second circuit is given by this value. So that's what you are supposed to do. Ensure that you go through the solutions and correct on the mistake that you may have committed. Know that when I was marking the scripts, I was over lenient, as you can see from your scripts, which will not be repeated in the final exam. So ensure that you do the correct thing on the final exam to get high scores. Thank you.